Most solids offer some amount of resistance to the flow of current through them, and this allows us to define things like the resistivity or the conductivity, but the same is true for liquids. Consider this container full of a liquid. We can measure its resistivity. Now, if I took a battery and I put one lead here and one lead here, if there's a voltage and this liquid is able to conduct electricity, then this current should be able to flow through the intervening liquid over to the other side and then back up. Now, sometimes this is done with AC current, otherwise you might get electrolysis and then you get bubbles in here and that changes the liquid in some way. And we want to measure the resistance and the resistivity of the liquid, not of some altered liquid. So sometimes you use AC, but this is the general principle. Send in a voltage, a certain amount of current will flow. How could we use that to determine the resistivity? Well, we know resistivity is equal to the resistance that we measure times the area divided by the length. And now you see there's kind of a problem. Length, I can imagine getting that. This length in here would just be this distance. There's my length because my resistor, quote unquote, is this liquid in here. But what's my area? So this would be a bad experiment to do. If we want to measure the resistivity, what we really want is something where we have a well-defined area. So let me get rid of this. And imagine you had two plates. Take these two plates, you put them in the solution you want to measure the resistivity of. So we put them in here, stick them into there. They have a well-defined area. We've got those. We can measure those if we want. We set them apart, some known distance between them, L, and you hook them up to a battery. So take this one, hook it up to a known voltage, hook the other side up to the other plate, and if this solution, if this electrolytic solution in here can conduct electricity, current will flow from this side to the other side, and you can measure these quantities. You measure the length, that's easy. You measure the area, you got that. How do we measure the resistance? Well, we know the voltage. We can have a known voltage of the battery up here, and you can stick an ammeter in here to measure the current. So if I stick an ammeter, ammeters measure the current. Now I could just use Ohm's law, and I know that the resistance is just going to be the voltage divided by the current. And if I plug all these values into here, I can get an experimental value for the resistivity of this liquid. Sometimes it's called the electrolytic resistivity. Or 1 over the electrolytic resistivity would be the electrolytic conductivity. So this would be the electrolytic conductivity. So this is an experimental way to do it. Honestly, you don't even have to go through all that much trouble. You can just take a solution, first put a solution in here that has a known resistivity. That way, you can just do this, R equals rho L over A. If you know the resistivity and you can easily measure the resistance, then you can just figure out what this constant is, and this will stay the same. You just leave those same plates in there with the same length and the same area, put a new solution in there, and that gives you this number, and this number is staying the same. So technically speaking, you don't have to go in there, measure the area each time and the length between these each time if you have some calibrated electrolytic solution where it has a known resistivity. Or you could use it the other way. If you had a solution with a known resistivity, but there may be impurities in there, or there may be dissolved salts or something, and you want to know what the concentration is, well, that's going to directly affect how much current will flow, and it'll directly affect the measured electrolytic conductivity. So if you measure this and it comes out different from what you'd expect from a baseline solution, you can figure out what the concentration is of the conductive impurities within this solution.